Let's understand how to convert an entity relationship diagram to a relational schema. An entity relationship diagram, also known as an ER diagram, is a visual way to represent the structure of a database. Relational schema is a more formal way to define how the data is organized in the database. It uses tables, columns, and relationships to represent the data and the connections between them. This is all about taking a conceptual ER model and turning it into something that can be implemented as a relational database. Now let's look at the overview of the mapping process. First, map regular entities. Each strong entity type becomes a relation or table with all simple attributes as columns. Second, map weak entities by creating a relation that includes attributes of the weak entity, plus the primary key of its owner entity. Third, map relationships. Binary relationships are mapped based on their cardinality, like one-to-one, one-to-many, many-to-many using foreign keys or relationship tables. Finally, map attributes, handling multi-valued, composite, and derived attributes with appropriate relational structures. Let us understand how to map the regular entities. Here's the ER representation on the left. We have an entity named student. The attributes are student ID, which is the key attribute, name, email, and date of birth. These are all regular attributes. The arrow shows how this maps to the relational schema on the right. We create a table named student. It has columns named student ID, which is the primary key, name, email, and date of birth. The mapping rule here is, create a table for each regular entity. The key attribute becomes the primary key, and all simple attributes become columns in the table. Now let's see how to map weak entities. Here is an ER representation with two entities, department and project. Department has attributes department ID, which is a key attribute, and department name, which is a regular attribute. There's a one-to-many relationship, contains between department and project. Project is a weak entity with attributes project number, which is a partial key attribute, project name, and budget, which are regular attributes. Here's how it maps to the relational schema. We create a table for department with columns department ID, which is the primary key, and department name. We also create a table for project with columns department ID, which is a foreign key referencing department and part of the primary key, project number, which is part of the primary key, project name, and budget. The weak entity rule is to create a table that includes the primary key of the owner entity as a foreign key, and the partial key of the weak entity. The combined primary key is the owner's primary key, plus the weak entity's partial key. Let's understand one-to-one relationships. Here's the ER representation. We have two entities, employee and parking spot. Employee has attributes employee ID, which is a key attribute, name, and salary, which are regular attributes. Parking spot has attributes spot ID, which is a key attribute, location, and floor, which are regular attributes. There's a one-to-one relationship assigned between employee and parking spot. Now look at the relational schema. We create a table for employee with columns employee ID, which is the primary key, name, salary, and spot ID, which is a foreign key referencing parking spot. We also create a table for parking spot with columns spot ID, which is the primary key, location, and floor. For a one-to-one relationship, we have mapping options. We can place a foreign key in either table, typically in the optional side. We can add a not null constraint to the foreign key if participation is total. We can add a unique constraint on the foreign key to enforce one-to-one cardinality. Let's explore the one-to-many relationships. On the left, the ER representation shows two entities, department and employee. Department has attributes department ID, which is the key attribute, department name, and location, which are regular attributes. Employee has attributes employee ID, which is the key attribute, name, and salary, which are regular attributes. There's a one-to-many relationship, work signed between department and employee. See the relational schema on the right. We create a table for department with columns department ID, which is the primary key, department name, and location. We also create a table for employee with columns employee ID, which is the primary key, name, salary, and department ID, which is a foreign key referencing department. For one-to-many relationships, the mapping rule is include a foreign key in the table for the entity on the many side. The foreign key references the primary key of the entity on the one side. If participation is total, add a not null constraint to the foreign key. Let's delve into the many-to-many relationships. Here's the ER representation. We have two entities, student and course. Student has attribute student ID, which is the key attribute, name and major, which are regular attributes. Course has attributes course ID, which is the key attribute, title and credits, which are regular attributes. There's a many-to-many relationship in roles between student and course. The relational schema is shown here. We create a table for student with column student ID, which is the primary key, name and major. We create a table for course with columns course ID, which is the primary key, title, and credits. And very importantly, we create a new table called enrollment with column student ID, which is a foreign key referencing student and part of the primary key, course ID, which is a foreign key referencing course and part of the primary key, semester, and grade. The mapping rule is, create a new relation called a junction table for the relationship. Include foreign keys to both participating entities. The primary key is the combination of both foreign keys. And include any attributes of the relationship as columns in the junction table. Now we will explore the special attribute types. The ER representation includes an entity called employee. It has attributes employee ID, which is the key attribute, name, address, which is a composite attribute with sub-attribute street, city, and state, phone number, which is a multi-valued attribute, and age, which is a derived attribute. Let's look at the relational schema. We create a table for employee with columns employee ID, which is the primary key, name, street, city, state, and age. We also create a table named employee phone with columns employee ID, which is a foreign key referencing employee and part of the primary key, and phone number, which is part of the primary key. For composite attributes, flatten them into individual columns in the entities table. For multi-valued attributes, create a separate table with a foreign key to the parent entity. Derived attributes can be included as columns or calculated via views or queries. Now let's understand inheritance. The ER representation has a parent entity, person, with attributes person ID, which is the key attribute, name, and email, which are regular attributes. There are two child entities, student and faculty. Student has attributes major and grade point average, or GPA. Faculty has attributes department and rank. Here's the relational schema using a single table approach. We create a table for person with columns person ID, which is the primary key, name, email, type, major, GPA, and department. This combines all attributes into one table. Alternatively, using a multiple table approach, we create a table for person with columns person ID, which is the primary key, name, and email. We create a table for student with columns person ID, which is a foreign key referencing person and part of the primary key, major, and GPA. Finally, we create a table for faculty with columns person ID, which is a foreign key referencing person and part of the primary key, department, and rank. Here's a summary of what we've covered. Regular entities map to tables with attributes as columns. Weak entities include the owner's primary key as part of their primary key. One-to-one relationships use foreign keys with unique constraints. One-to-many relationships place foreign keys on the many side. Many-to-many relationships require junction tables. Multi-valued attributes require separate tables. Composite attributes are flattened into individual columns. Inheritance can use a single table or a multiple table approach. When designing databases, it is best to maintain referential integrity with foreign key constraints, use appropriate data types for attributes, apply normalization to reduce redundancy, document mapping decisions for future reference, consider performance implications of design choices, and validate the final schema against original requirements. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.